Hello, students, and welcome to our new unit in algebra. This is a very brief unit on direct and inverse variation. We will have 3 lessons, 3 homeworks. All of that will be due on Friday, and we'll have a short quiz on Friday as well. But before we start, we're going to thoughtfully respond to a prompt about bullying. And we're going to talk about bullying in an environmental context. Our objective today will be to begin our short unit on direct and inverse variation. And for today, we will explore direct variation. So our essential questions are: what is a direct variation relationship? What is the constant of variation? And how do I identify direct variation equations? So as we watch the video, we will complete 2 pages, and there are 25 problems in all today. For our exit ticket, we will complete these thoughts. A direct variation is a specific relationship in which there is a constant what between 2 variables. Direct variation equations are written in what form, and what do we call the k, or what are we referring to with this k in this direct variation relationship? And all work will be turned in on Friday. So for tonight, you have 26 problems, homework 1, a direct variation. So you know what to do to get full participation credit. Your work will be due Friday. There's my email address if you have any questions. Also, Friday, we have a superhero virtual day. You can represent a real or fictional superhero. Friday, we'll have that quiz on direct and inverse variation. And you will be permitted to have your notes and homework with you. And having those complete and up to date will be highly beneficial so that you can get done in one period. That's all you'll have to do it. So this is our Spirit Day flyer. We have one Spirit Day left after today, which is Superhero Day. So let's talk about this bullying. Environmental factors can contribute to bullying. Is the cafeteria, that's what we're talking about here, a place where bullying takes place, and why? We've talked about bullying over the internet. We've talked about what causes people to bully. But one thing we haven't talked about is this notion that some people feel more empowered to their bad behavior in certain places rather than others. And how does the cafeteria contribute to that? Do you think that because certain teachers are not present or because there are more students there? Why do you think the cafeteria might be a place where bullying takes place? And what are those factors? And when we think about it in terms of the environment, it helps us to understand it a little better. And if you're someone doing that, think about your behavior and think about how the environment contributes. So I'd like you to write a thought right there. You can use the draw tool or the typing tool in Teams, and we will come back to our exit ticket. Let's get to our lesson. So our topic today is direct variation. And I think I want to start today by looking at a graph. So let me bring that up. So here's a graph. And let's just look at the red graph first. We'll turn off the blue one. So we can see here's our x-axis down here. And there's our y-axis. And the graph is the graph of the equation y equals 10x. And let's think about this equation in a real world way. And let's think of it as earning $10 an hour for having some kind of a job. So if you earn $10 an hour, then if you work a half an hour, let's adjust the graph. If you work a half an hour, you earn half of $10. Let me get the graph back to where I want it. So if you work a half an hour, so let's find 0.5 on the x-axis. And so you would earn $5. 0.5 on the x-axis is 5 on the y-axis, $5. If you work 1 hour, you make $10. There it is, right there. If you work 2 hours, you make $20. And if you work 3 hours, you make $30. Pretty simple. So this is a direct variation graph. Now, I'm not showing you the negative side of the graph because in this particular case, earning money, that would be inappropriate. You're not going to earn negative dollars. Let's think of another scenario. What about if you're driving a car at a steady speed and you're driving 30 miles an hour? So we have y equals 30x. So if you drive 1 hour, how far have you gone? So the x-axis will be your time in this case, and the y-axis will be how far you've gone. So if you've gone for 1 hour at 30 miles an hour, then you've traveled 30 miles. If you go an hour and a half, then you've traveled 45 miles. There it is. If you've traveled 2 hours, then you've traveled 60 miles. So again, another example of direct variation. Now, if you look at both of these graphs, you'll notice they're linear. You'll also notice that they both go through the origin, the point 0, 0. And I want you to keep that in mind as we talk more about direct variation. So that's a little introduction to direct variation. Let's get to our worksheet. So what is direct variation? Okay, a direct variation is a specific relationship in which there is a constant ratio, and that ratio is y over x between two variables. So if we go back to the Desmos graph, we have a constant ratio. Let's look at the paycheck one, $10 an hour. For every hour, we earn another $10. So if we work for 1 hour, we've earned $20. If we work for 2 hours, we've earned $20. If we work for 3 hours, we've earned $30. So that's that constant ratio between the x and the y. And we say the ratio is y over x. Well, the constant of variation, the variable that we use to represent this, is called k. Now, direct variation equations then are written in the form, they are functions, of y equals k of x, or k times x. So in the case, if we go back to our Desmos graphs, y equals k of x, our k here is 10. In terms of the car driving 30 miles an hour, y equals k of x, our k is 30. So it's a ratio of y over x where y equals k of x. Now let's think about this. What happens if we solve for k? Well, I'm going to go over here. If I have y equals k of x, and I solve for k, that means I have to divide both sides by x. And I've isolated k equals y over x. That's that ratio that we're talking about. So the first thing we're asked to do is to identify the constant. We're going to identify the k of the ordered pairs, and then we're going to write a direct variation equation to represent the relationship. So if I have points x and y, okay, x and y, and each of these points, okay, and I test them out. Here's my y over x, and our x is 1. Well, 4 over 1 equals 4. Now let's try it with another pair. How about the 8 over 2, y over x, also equals 4. So our k equals 4, and our direct variation equation is then y equals 4x. So let's look at number 2. We'll use the first point. K equals 3 over negative 6, which reduces to negative 1/2. So our k is negative 1/2. So our equation, y equals negative 1/2 x. That's number 3. We're given ordered pairs in the form of a table. So k equals y over x, which is negative 8 over negative 12, which reduces to negative 2/3. So our direct variation equation will be y equals 2/3 x. Remember, each one of these has to give us the direct variation relationship of 2/3. Now, we'll talk about this in a couple of minutes. But meanwhile, y equals 2/3 x. Let's look at number 4. We can test this first point. K equals 12 over negative 4, which simplifies to negative 3. And this would work with all of these. So our direct variation equation, y equals negative 3x. Now you'll notice that all of these, let's change our color, seem to sort of look like what kind of an equation? Do these seem to look like the slope-intercept form of an equation? Y equals mx plus b. And in fact, that's what they are, but in all cases, our b equals 0. So there's no b value here. We don't have a 2/3 x plus 0 or a 4. Well, it is plus 0, but we don't write the 0. So let's go back and look at our graphs again. So in both the case of the $10 an hour or the 30 miles per hour, both of these go through the origin 0, 0, because the b value of each one of these equations is 0. This is y equals 10x plus 0, y equals 30x plus 0. So what we have is slope-intercept form with a b value of 0. And we're going to look at that again in a couple of minutes. But let's do some more practice. We're asked to identify the equations below that represent a direct variation. And if they are a direct variation, we're going to identify that constant of variation. We're going to identify the k value. So first we have number 5, y equals 3x or 3 of x. And that is a direct variation. And our k equals 3. So we're kind of doing the opposite of what we did in the last exercise. So the last exercise, we're given a k and we write the equation. Here we're given the equation and we identify the k. So y equals negative 4/5 x. Yes, that is a direct variation equation. And our k equals negative 4/5. Y equals 2 is not a direct variation equation. We need an x value. Now, look at 2y equals 5x. Well, we need to isolate y. So we will divide both sides of the equation by 2, which gives us y equals 5 over 2x. And that is a direct variation. And our k equals 5 over 2. The next equation, y equals 1x, there's an invisible 1 minus 4. Well, we said with direct variation, the b value must be 0. So no, because b is not equal to 0. But here, y equals negative x, we have an invisible 1. So this is a direct variation, and our k equals negative 1. Okay, so y equals negative 1x, but the 1 is invisible. And we just have the negative sign. So try the next 3 on your own, and let's see how you do. So for number 11, we need to divide both sides of the equation by 2 so we can isolate y. And when we do that, we have y equals 1/2 x. So this is a direct variation, and our k equals 1/2. And let's solve for y in this equation. First, we'll subtract 4x from both sides. And then we have 2y equals negative 4x plus 6. Then we divide everything by 2. And we end up with y equals negative 4 over 2, which is negative 2x. 6 divided by 2 is 3, and the answer is no because of this b value of 3. So this is not a direct variation. And in the last one, let's isolate y. So we'll subtract 5x from both sides, which will give us y equals negative 5x plus 0. We don't even have to write that. We know that this is a direct variation equation, and our k equals negative 5. Now, moving on, let's look at some direct variation graphs. So identify the graphs that represent a direct variation. If yes, identify the constant of variation. Okay, let's look at number 14. So what we're looking at is the slope. We have a rise of 3 and a run of 2. So we have a positive 3 over a positive 2. Let's keep checking. 3 over 2. So, and we go through the origin, 0, 0. So it looks like, yes, we have a direct variation relationship where k equals 3 over 2. And our equation will be y equals 3 over 2x. Now let's write the equation of the next of number 15. So we have a slope of negative 1 over 2. So our slope is negative 1/2. And we have a b value of 1, 2, 3, 4. So the equation of this line is y equals negative 1/2 x plus 4. And if we don't go through the origin, we don't have a direct variation relationship. Number 3, we have a slope of negative 1 over positive 4, negative 1 over positive 4. So our equation, and we go through the origin. So it looks like we have direct variation. It looks like our k equals negative 1/4. So our equation will be y equals negative 1/4 x. And finally, number 17. We do go through the origin, the 0, 0. We have a slope of 3/3. And let's check it out here. 3/3. And 3/3 equals 1. So we have a direct variation, goes through the origin. Our k equals 1. So our equation will be simply y equals x. And that is a general parent function of all linear equations. So let's move on and see if we can find some missing values. So if we're given 2 points, we simply, and we're asked to find one. In this case, we're asked to find y. Well, we know that direct variation is a ratio of y over x. So if it's a constant ratio that remains the same, then the first point and the second point should have the same ratio. If we're told they are direct variation, then we're looking for them to be the same ratio. In other words, we know that we can set up a ratio of y over x equals y over x. But one of these will be missing. So either first y, the second y, the first x, or the second x, something will be missing. So all we need to do is set up a ratio of the 2 points and solve for the missing point. And in most cases, we can just multiply, or in some cases, we'll need to use the distributive property. I don't think any of these are that hard, but let's set it up. So we have here, we have x, y, x, y. So -4/2 is equal to, now here's our missing y, over -6. So we just solve it using cross products. So 2 times y equals -4 times -6. So 2y equals -4 times -6. 2y equals 24. We divide both sides by 2, and y equals 12. Okay, xy, so 16/4 equals 24/x. So 16 times x, or 16x, equals 24 times 4, which is 96. We divide both sides by 16, and x equals 6. Just use cross products. So let's try the next 4 and see how you do. So we've got y over 12 equals 7/4. So 4y equals 84. Divide both sides by 4, and y equals 21. Next to number 21, -16/x equals 24/6, which means 24x equals -6 times, -16, times 6, which will be -96. Divide both sides by 24, and x equals -4. Number 22, be careful when you read these, the language. If y equals negative 18 when x equals 3, this is what we're talking about. X is 3, y is negative 18. Find x when y equals 30. That's what they're giving us. So negative 18 over 3 equals 30 over x. So negative 18, x equals 30 times 3, which is 90. Divide both sides by negative 18, and x equals negative 5. Now, if y equals 80 when x equals 32, find x when y equals 100. This is very similar to the problem we just did. So we have 80 over 32 equals 100 over x. That would mean, I'm going to change the color so we can see it clearly. That would mean that 80x equals 32 times 100 is 3,200. Divide both sides by 80, and x equals 40. All right, last two problems. I hope you're trying them yourself. If y equals 10 when x equals negative 4. So we have negative 4, 10. Find y when x equals 12. Let's set that up. 10 over negative 4 equals y over 12. So that would be negative 4y equals 10 times 12, 120. Divide both sides by negative 4. And y equals negative 30. And the last problem, if y equals negative 7 when x equals negative 28, find y when x equals 20. So x is 20, we'll find y. So negative 7 over negative 28 equals y over 20. And that will be negative 28y equals negative 7 times 20, which is negative 140. Divide both sides by negative 28. And y equals 5. Negative divided by negative is a positive. 140 divided by 28 is 5. So that's direct variation. Intuitively, all along, I think you guys kind of understood it because we've been working so much with linear equations, but now you have this very special relationship. You'll see that you've noticed the graphs all go through the origin, and there's a constant variable, k, which is our constant of variation. So a direct variation is a specific relationship in which there is a constant ratio of y over x between two variables. The constant of variation, k is the constant of variation. And direct variation equations are written in the form of y equals k times x. Hang on to your work. You'll be photographing it and turning it all in on Friday. Do homework 1 tonight. Make sure you get it done. Don't wait till Thursday night to do it because you'll have too much to do, and you need to understand this before we go on to inverse variation tomorrow. So keep up the good work, keep practicing, and you'll be great.